Okay, so now we're moving into part 2 of the lesson. And when it comes to these problems, we do have to take our time with these, okay? These ones are a little bit different because you'll notice a lot of these are equal to something. And because of that, we got to solve them a little bit differently, but that's okay. We can do it. All right, so these problems are equal to 0. And essentially what we're saying is something times something equals 0. And there's a property that when you multiply stuff gets you to an answer of 0. And so because it's a property and because we're multiplying, which is the product, then we call that thing the zero product property. All right. Now I know I've mentioned this in class, and so if you know what to do with these, just start working through these and see what you get. If you don't know what to do, then let's do these guys together. So this first one up here, let me just rewrite it. I got 2d plus 6 and 3d minus 15 equals 0. Okay, so really what you're trying to do here is say, okay, I know that this guy equals 0, or this guy times this guy equals 0. Now, the book is going to teach this in one way, and I want to talk about it in 2 different ways, just so that if you are pretty quick with this stuff, then maybe you'll just jump to plan B. But let's take a look. So let's go problem by problem, okay? I know that this times this equals 0, and so therefore, because of that, I know that this guy, 2d plus 6 equals 0. And I know that 3d minus 15 also can equal 0. What I'm trying to do is solve for these letters that are inside here and figure out what values for d or x or a can I plug into these 2 problems to make this guy equal to 0 or this guy equal to 0. And so the more standard way to do this is to solve them one at a time and say, okay, well, because I know it's this times this equals 0, I know that this guy, if this guy is equal to 0, then anything times 0 is just going to be more 0. So is that even the right way to say that? I don't know. But anyways, I know that anything here if this becomes a 0, then I know it doesn't matter what else there is because 0 times anything makes a 0. So I can solve this old school, I can subtract 6 from both sides. 2d equals negative 6, divide by 2, so d equals negative 3. Okay? So I'm going to leave this here for just a second. Then I want to walk through this guy. Okay, same thing. Let's solve this guy for d. And again, I know I went pretty quick through this stuff over here, but this is Algebra 1. If I go too fast through solving these equations, I do have other YouTube videos where I work on just solving equations, moving stuff side to side, and coming up with your answer. So again, maybe you just need to go back and double check this stuff. I know I went kind of quick, but I am going to leave it up here so you can just take another peek. Okay, let's see here. Plus 15 on both sides, so I get 3d equals 15, divide by 3, d equals 5. Again, I know I go kind of fast through this part, but that's not Algebra 1. Like, that's pre-algebra. You should understand how I'm solving these guys. And now the next level is when we're actually applying this stuff that you learned a while back. Okay, so now I have my 2 values and I'm just going to double check them. Usually, what does the book say here? Solve each equation and check your solution. Okay, so really what they're saying is plug in this negative 3 right there and see if this all equals a 0. 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. Therefore, this guy works. Over here, let's plug in the 5. 3 times 5 is 15. 15 minus 15 is 0. So therefore, my answer, which again, moving into the next couple sections of the book, these are going to be called the roots rather than just the answer. My answers here are d equals negative 3 and 5. And so those are my final answers. I have 2 different values that work for this situation. And if you were in class recently, this is where we talked about these are values for the roots. Remember, the roots are the 2 points where a parabola crosses the x-axis, and that's what we're moving towards, which is why we're now setting these equal to 0 using this zero product property. Because when y equals, oops, that's probably not accurate, it's more like there. Because when y is equal to 0, right, I don't go anywhere up and down, and I go side to side, then if y is 0, then x is -3. Y is 0, x is 5. If that part doesn't make sense yet, that's okay. That's a totally different lesson. We're moving in that direction. But I do like to talk about why we're using some of this stuff and learning it, so you're not just like, dude, I have no reason to learn this. I don't even understand what you're doing. Why are you even solving these problems? Okay, it's because we're working on this so that we can apply it to more challenging problems in the future. So let me just kind of move this guy out of the way and move on to the next one. Now, when they're saying solve, they're looking for you to come up with some form of an answer. And right now, instead of having one answer, you're ending up with 2. So I always say write your answer as D equals, and then just list them out in numerical order. Let me see, does this book even care what order they're in? It looks like they do the negative number first, then the positive, just because on the number line, like left to right, that's where they would show up. But if you're doing all this awesome math and getting the 2 values, I think that's pretty cool. The only thing I don't want you to do is put parentheses around this, because if you do that, then it's an ordered pair. And we're not dealing with points on a line or points on a coordinate plane. So don't do that, okay? Just leave them as answers or values. Some teachers will say, hey, if you can get this far, that's awesome. You don't even need to rewrite it. But it kind of depends how you want to structure your work. I'm okay if you get this far. If you don't want to rewrite it on your homeworks, that's okay. But at the least, check your answers and just make sure that you end up with 0. Now, if you're a little bit quicker with this stuff, rather than going through that, some people say, Josh, can I just look at this problem over here and say 2 times something makes, I need this to make a -6 because I have a +6 right here. So if I know 2 times something has to become a -6, can I just multiply this by a -3? Yeah, you can. Can I just multiply this guy over here to make it a +15? Can I just multiply it by a 5? Yeah, you can. And so if you're just cool like that and you don't want to solve this, or you don't, the numbers are kind of small, that is kind of a quick way of solving these as well. It's not the recommended method. Books and teachers are going to prefer that you show all this work so you really do understand what you're doing. But that is a quick way for you to solve these as well. Okay, and students bring it up, which is why I want to bring it up in the video so that you don't feel like this is the only way it can be done. Now you have 2 different methods. This way I think is very nice and clean, very straightforward. This way is going to be a little bit more, you just got to be good with your numbers. Okay, and if you're not, that's okay, because for the most part, you should have enough time to do all this stuff and be able to complete the problems in your class or wherever you're doing these things, sitting at home, relaxing while I'm doing all this math for you, or with you, I guess. Okay, this guy here, C2 and 3C. C2 equals 3C. So because I don't have anything equal to 0, I need to make this thing equal to 0. And so in order to do that, I'm just going to move this guy over. Well, how do I do that? I need to subtract. Remember, if I'm going to move stuff across the equal sign barrier here, I do have to be able to add and subtract and move them around. So I subtract 3 C's from both sides. I'm just going to rewrite the problem here. I got C squared minus 3C equals 0, right? Because now there's nothing left on that side of the equation. So I can just say c squared minus 3c equals 0, and now I can work on this problem. This one's kind of tricky, but if you remember, we were working on those factoring problems, which is why this problem is actually a part of this section of the math chapter. Can I pull something out of both of these guys equally? Yes. The letter C. How many C's can I pull out? Just one. Okay. So then what's left? I end up with C minus 3 equals 0. So, looking at the outside over here, what number could I put here that would give me a 0 through the rest of the problem? 0. And it's weird for 0 to be an answer, but it is. So let's just write it down. And then, so this guy's now taken care of. And then what number could I put there so that I end up with something minus 3 also equals 0? I can put a 3 there. Sorry, I know I kind of talked through that part kind of fast. But again, I want you moving pretty quick through these problems and stuff like that. I'm hoping that you're seeing it on the first time. And if you're not, maybe just go back one more time and watch the video and see if that helps. Alrighty, so now I have my two answers of 0 and whatchamacallit. Let's see here, 0 and 3. Again, you can write it out like this. If you wanted to just circle them, you could. It's up to you. And then move on to the next problem. All right, let's see here. I got 3k k plus 10 equals 0. All right. So in this problem here, they've already done the factoring for you. So that's kind of nice because you personally don't have to like bust stuff apart or come up with new answers or do anything crazy. They've already put it in a pretty straightforward situation here. And so now it's just a matter of looking at it piece by piece and saying, what numbers can I put there to make these parts equal to 0? So 3 times something can make it a 0. Oh, I can say that k has to be equal to 0. And then what number can I put here to make this guy over here equal to 0? -10. And so at that point, you're done. That one actually wasn't too bad. Let me just double check, right? I'm kind of doing these on the fly, and I just want to make sure that as we do these, that we do have correct answers, because that would actually be kind of a bummer if they weren't. So that one, you know, was pretty straightforward because all I had to do was figure out what goes here and what goes here that would make these guys equal to 0. All right, case closed. Move on to the next problem. As I said before, if you have questions, send me an email, send me a message, do something, okay? Try these on your own, you know? I mean, it's going to really help you out if you try these, and even if you make some mistakes, you know? Like, we're going to be doing these for a while, and I think over time, if you keep practicing, you'll get it. Okay. This one was a word problem, something about a dog. The dog, let's see here, the dog has to jump over a hurdle. This is the equation for it. And so find the values of t when h equals 0. Zero product property, ZPP, coming right back at you. Okay, so they're saying find the values of t when h equals 0. So, not to get too mathy right now, but again, this is another situation. This is your vertical motion model and stuff like that, which we'll get into later. But we have another situation here where we have h, or the y value, being equal to 0, so that we can then find the roots here, right? Because this dog jumped. I don't know if he started on the ground or not, whatever. It doesn't look like he did. Or he did start on the ground, so I guess this could be moved over. But when y is equal to 0, what are these roots going to be? And then that's going to help us determine the answer of where this dog jumped. Okay. Or from a height of 0, Well, how high did this guy go? Okay, whatever. And again, if that part makes sense, that's awesome, because that's where we're headed with all of these quadratic equations and parabolas and all this kind of stuff. If it doesn't just yet, that's okay, because we're going to spend some time working on those in the next couple weeks. Okay, so it did say find the values for t when h equals 0. So I'm just going to rewrite the problem now, because that way I can work on it down here. Okay. The nice thing about this stuff, or as a teacher, the reason I like teaching it, is because you're really applying a bunch of different ideas all at the same time. And so for you to solve this guy, you got to start thinking about, well, what do I know? What am I allowed to do within the rules of math? And then how can I apply it to these guys? Well, is there a way that I can factor this guy? Yes. Okay. What's the greatest number I can pull out of both of these parts? All right. And like I said, when it comes to these ones here, you're trying to pull out the greatest common factor between these two parts here. So the greatest common factor here is a 4. And again, you could do your factor trees. Remember in the previous lesson how you write out the number 16 and then you like have all your factors and you get 2 times 2 times 2 times 2. And then over here you have a 20, which is a 2 times 2 times 5. And you go, oh, a 2 can be pulled out and a 2 can be pulled out and a certain amount of t's. Well, 2 times 2 is 4. And then what's the most amount of t's that I can pull out? Just 1. So now I can rewrite the rest of this guy here. Sorry, I just want to make sure that we're following perfectly along with this book here, because that way it all matches up nice and neat. Okay, so I pulled out the greatest common thing, and now I'm just rewriting whatever is left. So 4 times what gives me a negative 16? Negative 4. T gets to become a t squared by adding a t. And now I got the back part here, 4t, or a 4 times something gives me a positive 25. And then I have t. So because I already have a t there, I don't need an extra one. So I'm pretty much just done. And so now some books are going to say, hey, take this problem and work on it like you did that first guy, right? Where you're going to set this guy equal to 0, so you end up with 4t equals 0, and negative 4t plus 5 equals 0. Solve these solve these guys and get answers. 4 times something gives you a 0, so t equals 0. Over here, I would subtract 5. Negative 4t equals negative 5. Now, if this is working for you when it comes to doing these problems, and I know I'm going fast, but this is a video that I want you to be able to pause, go back over and re-listen if you need to, but maybe this is your speed and you're like, dude, this is perfect. Okay. The books are going to encourage you to work on them separately like that and solve for t. So t equals 0 over here, right? Because 4 times 0 is 0. And then over here, I subtracted, I moved the number to the other side. Now I got to divide by negative 4. So I end up with t equaling 5/4. I hope this is still on the camera. T equals 5/4. And t equals 0. Okay. Now, this is a pretty quick way to do these because you're just making this guy equal to 0 and getting your answer. The last little tidbit I want to give you is there is a quicker way to solve this type of problem, okay? You could do it this way every single time. Again, it's going to work. So if this is your deal, then this is how you should solve these problems, because you're going to, as you've practiced these, you're going to get faster because that's you, right? You're like, I'm good at this, separate these, solve them for t, x, b, whatever, and then just get my roots and I'm done. Or the quicker way to solve this guy over here is to say, well, I have negative 4t plus 5. So what value could go right here? And the quick way of doing this is to just take Well, I have a 4 here and I have a 5 here, and we know the answer is 5/4. Okay, and so in order to make this guy plus this guy equal to 0, I can just say, oh, well, in order for me to get that value that goes there, I just take these two numbers and make it into a fraction. 5/4. You take the back number here and put it on top of the other number, and then boom, that's your answer and you're done. Okay? For some people, they're like, wait a second, dude, that's way too fast. Like, how did you even do that? Okay? But it works. You just take that number and divide it by the other number next to it, because that just gives you that answer. It cancels out. If none of that makes sense, you know what? Let me just write it out, okay? I got -4 times that plus 5. All right, so now let me erase this. And let's just see what actually happens. So -4 is the same thing as -4/1. If I were to multiply this straight across, right, that's how we multiply fractions. -4 times 5 is -20. 1 times 4 is 4. -20 divided by 4 is equal to -5. -5 plus 5 equals 0. So that's where this all came about. And it's not usually taught in a lot of books because they want you to practice that very standardized method. But as you get better at this, you can take that shortcut and just start to say, oh, well, if I need the fraction here that's going to make this and this equal 0, I can just use those two numbers, turn them into a fraction, and boom, I'm done. Okay. All right, so we finished this part. At this point, I would say start trying some of these problems when it comes to factoring these guys. And then we're going to be moving on with that zero product property in the next section. So make sure that this one is starting to become clear, okay? We're going to take our time with this. I don't want you stressing out. If you have questions, feel free to send me a message, email, however, through OneNote, whatever way you can get a hold of me and ask a question, then do it. But if you watched me do all these problems and they all make sense, then try the homework, try some more problems on your own. And then in a couple of days, we'll just keep on going and we'll keep adding to what we're able to do with all of this stuff. Okay? All right, so good job. Follow these lessons. Watch them again if you need to. And for the most part, try these on your own, because if you fail and make some small mistakes, that's okay. You're going to learn from them. All right, you got this. Let's get back together in the next video, and I will keep on going with this math.